Okay, good morning, ladies and gentlemen. For those of you who do not know me, I'm Norman Howell. I'm the CEO of the Pipeline Industries Guild, and I'm also a UKSTT council member. And I'd like to welcome you to this Green Alliance webinar on Severn Trent's approach to generation and use of sustainable energy. The Green Alliance is a partnership between the Pipeline Industries Guild and UKSTT, and we've joined forces to explore, share and promote industry's drive towards net zero emissions and reductions in environmental impact. Now, for those of you who are not familiar with the Guild and UKSTT, I'd like to just give you a short introduction to both of them. So the Guild's key objectives are to promote pipelines, connect people and advance pipeline technology. It provides a platform for all who are involved in the pipeline industry to share best practice and technological development. The UKSTT is the only UK society dedicated to promoting the use of trenchless technologies for the installation and repair of underground utilities. And it looks to share and advance knowledge and experience of using trenchless techniques to provide a more efficient, environmentally friendly and cost-effective approach than using conventional open trench methods. Both organisations have a diverse membership that includes network owners, contractors, consultants, equipment and material manufacturers and suppliers. We've got members of academia and support services providers. And what we're doing throughout this year, the Green Alliance intends to hold a series of webinars, which is going to lead up to a face-to-face seminar at NODIG Live, which is taking place in Peterborough from the 14th to the 16th of September. I'd now like to just give you a couple of housekeeping rules. And I'd like to advise you that we are hosting a live question and answer session which will be undertaken after we've heard both of today's presentations. So could you please post any questions you may have in the Q&A panel on the GoTo platform. I think it's called Questions. And then also, can you also note that this webinar is being recorded and it will be available to view in a couple of days' time on the Guild and UKSTT YouTube channels. So now I'd like to hand over to our moderator for today, who is the Guild's current chair, Jason Wilson. So over to you, Jason. Thank you.
Thanks, Norman. Good morning, everyone. I'm Jason Wilson and I work for Severn Trent, and I'm honoured to be the Pipeline Industries Guild chair. It's great to be collaborating with the UKSTT on this extremely exciting subject. This alliance is already working very hard to exploit every opportunity to share and promote the industry's drive to making a positive environmental impact on our planet and working towards the net zero emissions that Norman's already discussed. So watch this space, because this will be a game changer. I'm absolutely convinced of it. So we're very fortunate. We've got two excellent speakers today. We've got Simon Farris from Severn Trent, and we've got Philip Woodcock of PBF Drainage Systems. Both are leading experts in this subject, and we're extremely appreciative that they've given us our time today. So I'm sure you'll have things that you'd like to ask them, but as Norman said earlier, we will have time for Q&A. We have a bespoke session after both of the presentations are finished. So without further ado, first up we have Simon Harris from Severn Trent. Now, Simon has worked for Severn Trent in a variety of operational roles before joining the renewable energy team back in 2011. And over the past 9 years, he's developed a number of energy projects, including the UK's first commercial sewage to biomethane plant at Midworth, which is in Birmingham. He's now the strategy and commercial lead for our bioresources group, and he's focused on the sustainable treatment of sewage sludge to produce energy and high quality biosolids for disposal onto land. You may actually recognise Simon from his appearance recently on the BBC Two television documentary, The Secret Science of Sewage. There may be more on that later, but let's see. I'll hand you over to Simon Farris. So if you could take it away, Simon.
Yeah, thanks very much, Jason. So if you want to skip on to the first slide, please, Alice. Oh, no. We got the slides available. It's always good when the technology starts well. So yeah, good morning, everyone. Yep. So my name's Simon Farris. Thanks for the introduction there. Yeah, so I am the Bioresources Strategy and Commercial Lead, which is quite a grand title, but it's looking after our sewage sludge AD strategy and how we're converting that into fantastic renewable energy and, as we said, some of the biosolids materials. So just, if I can just start on the next slide with some of the background to why we do what we do. So we can just skip it on one. There we go. So at Severn Trent, we've recently, February 2020, feels recently because we've all been inside for the last 12 months. We announced to the city our triple carbon pledge, which is really important across the industry. It's something the industry as a whole is very supportive of, but our specific one is focused around these 3 targets, and that's that by 2030, 100% of the energy that we consume will come from renewably generated sources, that we will achieve net zero carbon emissions across all of our activities, and that we will operate 100% electrical fleet. And I always put the caveat where the technology allows, which we'll go into a little bit later on around some of our HGVs and things that are going on there. Now, it is actually sort of quite neat that we have already managed to meet the first, or certainly a good chunk of the first one of these through a large scale power purchase agreement. But we don't want to be satisfied with just buying it in from other people. We're actually looking at how we can do more with our own generation. So we'll be focusing on different energy kinds as well as improving our electricity generation. And as part of that, energy from waste has a huge role to play. So when we convert the energy into biogas and biomethane, we have a huge opportunity as a power generator. It can be used to generate heat. It can be moved through the networks. And it can also potentially be used as a vehicle fuel, which again, I'll touch on a little bit later on. One thing that we've also signed up to is something called science-based targets. So the science-based targets Institute is a relatively new body that's also been looking at not just net zero emissions, where quite a high proportion of what you still emit can be offset with kind of purchases from other types of industries or generally sort of carbon capture technology. What we're talking about with the science-based targets is we'll actually have to make a genuine reduction in the carbon that we produce. So it means that offsetting will not be allowed. So it won't be a route for us to eventually get as low as we possibly can there. And also some of the things we look at in terms of our generation, we have to look at how we can do it better. So what this means is not only are we going to be generating renewable energy, but we're going to be doing it in a cleaner, greener way. So if we just want to skip on to the next slide. Okay, so in terms of the AD market in general, Severn Trent as a whole, as a PLC, we are one of the UK's biggest, certainly combined, we are the biggest operator of anaerobic digestion. So anaerobic digestion is the use of sort of large storage tanks to treat organic waste using bacteria. We'll go into the process a little more in a second, but basically this is the premium route for wet waste in the UK for renewable energy conversion. Now we actually as a business, we operate 2 anaerobic digestion businesses within it. So from the 1st of April 2020, Ofwat, the regulator, decided to set up a new price control for us Sorry, just having a few issues with the webcam. New price control for us, whereby our regulated anaerobic digestion activities, so that's kind of the sewage sludge element, will be put into a new price control called bioresources, where it could be competitive with other areas to see how we could develop a commercial market in this space, and we've been working in that one. We do also have Severn Trent Green Power. I'm not going to touch very much on those guys today. I used to work in that activity, so if you've got some questions, I can try my best. But they're focused on the stuff that would be classed as non-regulated. So what I mean by that is where we use anaerobic digestion to treat organic waste such as food waste or crops, so not waste in that case. And we can use the power that's contained within that food waste to generate biogas and biomethane that can be used. So from a sewage sludge perspective, Severn Trent Bioresources were responsible for the treatment of sewage sludge currently for around 8.3 million customers across the Midlands. And we do that through 27 sludge treatment facilities that we have dotted around the region. Now they're taking material in from approximately, well, it's just over 1,000. 1,008 is the number I've got there. Sewage treatment works that are spread from north to south across the region. So we go from all the way up on the Humber, all the way down to Stroud in the south. Out to the west, we're right on the Welsh border, where another of our neighbours is HD, as part of our PLC. We also then come all the way across to sort of Leicestershire, Nottinghamshire in the east. So quite a broad area and a large number of customers. And what that means is, we say around 234,000 tonnes of dry sludge every year will go through our plants. So quite a significant volume there. But that does come through as quite it's sort of very thin, watery material. So it's around about 4 million tonnes of water that come with it. So a large part of our business is understanding how we can get that dry sludge extracted from all of that water and converted into the energy that we want, because it's that dry material that contains the energy we're after. So we've been developing AD for many, many years now, sort of at least 50 or 60. We are the only landlocked water and waste utility in the UK, and as a result, we probably had to develop this technology a little bit ahead of the others who could still dispose to sea. So AD, we've been running it for 50 years now, and we still believe it's a fantastic technology, but there are lots of ways in which we can work on it, improve it, and increase the energy yields from the material we get. So if we can just step on to the next slide, please. So yeah, just a very quick overview for anybody who's not been involved in the waste treatment side of it. I won't spend too long on this. Obviously, it's available afterwards. But broadly speaking, when we look at a sewage treatment works, we have the inlet where we do sort of plastics, rag, and grit removal. So that's really important because we don't want to be filling our digesters up with this later down the line, as well as we don't want any of it coming through and obviously making its way through to final effluent and a watercourse. We then have, so in there's usually a solid separation, so usually a simple gravity primary type separation of the solid material out, known as the primary sludges basically. And then on most of our major sites, we'll also have a more intensive aerobic treatment that will allow us to get some of the sort of harder to obtain solids through. And finally, we'll have typically have a tertiary solids removal technology that will allow the final bits to gravitate out. And we, in Bioresources, we then take, at the boundary where it's the solids there, we'll take all that solid material, we'll take it through our AD process, and we will look to bring it out to the far end where we can produce electricity from the biogas that comes from the process. So you can see at the top there, we've got a couple of images. The one on the right, one of our first CHP engines going in back up at Strongford, back in, I think it's about the 60s or 70s, they were putting that one in. At the time, that would have been just designed to put a bit of power into the site and a bit of heat for the offices probably. The image on the left is what you'll find in the green shipping containers that you'll see dotted around wastewater treatment works. Much bigger, much more complex unit that allows us to produce much more power from the biogas being produced, and we recover heat off that engine to supply the digestion process. The other alternative, which was sort of mentioned briefly in my intro, is we can convert this into biomethane, so the gas that's coming off that AD process is around about 60% methane, 40% carbon dioxide. There's a few other bits and pieces in there, some impurities, but essentially we can take the 40% carbon dioxide out and we can have what is very, very close to pure methane that we can export into the gas grid. We do that at a number of our sites around the Midlands. Now, despite the bacteria in that AD doing loads of great work to destroy some of the solids that we don't want going through and we don't want coming out onto our disposal route, there is still a solid fraction that we have to dispose of. Now, the advantage of that is it's usually full of some really great materials that we can't get anywhere else. So nitrogen, phosphorus, potassium, all chemicals that we currently have to obtain through various extraction, mining type routes. These are naturally available in the sewage sludge. They've found their way through the food chain, through us, down the sewers and into this cake material at the back end. And so what we do is we work with our farm customers and some sort of very stringent legislation from the Environment Agency to allow us to use this as a biofertilizer that we can put out onto land and capture all the goodness that's contained within it. So that's the core process. If we go on to the next slide, please. So why do we want to do it? So I talked before, we've got that, obviously the waste disposal element is huge, but why do we want to convert it into biomethane? So raw biogas is actually quite an energy dense fuel. So it's 60% methane. You know, it's far better than some of the lighter fuels that are out there. If we can extract that 40% of CO2, we end up with what is quite an energy rich, sort of high value type material that can actually be converted into a number of different end uses. So I touched upon it in the last one. You can see the top use there, we can stick it into the gas grid. So the plant there is the first one we built at Minworth that was mentioned earlier. It's a water scrubbing technology. So we use basically around about 5 or 6 bar water, which absorbs the methane out of our biogas stream. And then when we release the pressure, absorbs the CO2 out of our biogas. So we can release the pressure and remove the CO2. Nearly pure methane comes off the top of that first column. We scrub it in some activated carbon beds and then we inject it into the national gas grid. And that opens up huge amounts of opportunity for either domestic or non-domestic high efficiency generators that are out in the network to use this gas as part of our national energy makeup. So a really great way to recover all of the energy that's contained in that biomethane and put it to the best use. One of the areas we're looking to develop into, so this one's currently quite hot. I think I've seen some stuff from Wessex coming out that they're shifting over some of their fleet at the moment. Biomethane to vehicle fuel. So biomethane as a compressed natural gas or even a liquefied natural gas, that is also an option. We can actually basically take it straight off that process in the top left-hand corner, compress it down, put it into a truck that would be able to move, well, we're now getting to the point where we can see tankers, so it'll be able to move 40 tons of material around the region. And obviously from a circular economy perspective, biomethane could have huge value here, that essentially the waste that we have to collect every day could be used to fuel the vehicles that go and collect the waste that is produced every day. So we end up with a really nice circular position. And when I talked about that triple carbon pledge earlier, this is a technology that is getting hard to decarbonize and hard to develop. So a really great option for us to look at how we can take carbon out of our vehicle fleet and really get to a great sustainable position on it. And finally, hydrogen. Can't really talk about renewable energy at the moment without talking about hydrogen. As the UK develops towards a sort of a greater hydrogen economy, we want to be a part of that. So there are some technologies which we're looking at which could go straight to hydrogen production, but probably the two most common at the moment are electrolysis, which is itself requires electricity input, but also there's steam reformation. So you can take methane as a core fuel and you can crack it to end up producing hydrogen and using carbon capture to make sure that it remains a green form of hydrogen. So even if we look at a step away to a hydrogen grid or a hydrogen economy in the future, methane will still have a core part to play in it if we're going to produce enough hydrogen to do all the great things that we want to do. So by producing biomethane, we've got a contribution that we can make far, far into the future, certainly out to 2050. Biomethane can have a huge part to play in the UK's transition overall to a low carbon technology, and hence why we're working so hard to produce as much of it as we possibly can. So we skip on to the next slide, please. So yeah, just said, it's a great option. And as part of our AMP7 plan, so that's the next 5 years, we're actually looking at how we can develop 3 new advanced AD sites. So these advanced AD sites do produce higher biogas yields from the dry feedstock I was talking about going in before. We already have one of these plants at Minworth. We have one of these plants at Strongford. We're actually in the process of, sorry, I should use the proper names, at Birmingham and Stoke-on-Trent. We're actually in the process at the moment of constructing a plant at Nottingham and a plant at Coventry, which are due for commissioning for the full THP later this year. But as we start to produce these increased amounts of biomethane, what we're also, increased amounts of biogas, we're combining that with biomethane. And currently, due to the government structure around its incentives, injecting it into the grid is the best way for us to go in terms of recovering that energy, getting the right support from the government, getting the right number of end users available to us. So from our perspective, the aim is, firstly, that we build these plants that can get more from what we already have. But secondly, I sort of mentioned it earlier, Ofwat is looking at whether we can open up the market a little bit and bring in either cross-border trading, or potentially in the long run, there is a potential for sort of standalone contracts or larger long-term contracts that we could bring more sludge into the region. So the sites that we have, we're looking at building enough capacity to be able to trade on those borders, to increase the amount of feedstock we have coming into our plants, generate more biomethane, and obviously make that huge contribution towards both our own energy consumption, but also the wider UK options. So yeah, by the end of the AMP, we're hopeful. We certainly have all those ones either built or in construction. We're hoping we might be able to get to 6 area hubs. So 6 down in the south there, you can just about see on the bottom of the screen, at Gloucester, or Netheridge as we refer to it. And down there, we're looking at whether we can consolidate some of our slightly smaller sites, pull together a south super hub, and again, add a biomethane plant onto that would allow us to increase the amount of biogas we produce, which increases in turn the amount of renewable energy, and also look at producing the highest standards of biosolids, that material recovery that we're looking at in terms of working with our farm partnerships. So huge amount going on in this space over the next 5 years. I think it'll probably continue for the 5 years afterwards. And what we're looking at is how can we build these treatment hubs near to our big cities so that we can deliver the best efficiency for our customers. That's the one bit I haven't really touched upon here. The other reason why we do this is because the income that we can generate for this means that we're treating the waste cheaper. And if we're treating it cheaper or more efficiently, what we can do is we can reflect that in our customer bills. So it ends up being a great perspective, sort of process for ending up with the better customer bills, the better carbon performance, the better renewable energy generation. So it's a win across the board. So we skip on to the next one. But it's not necessarily enough to just talk about the generation element of it. So renewable energy generation, I guess we've probably been looking at, so that first plant at Minworth for biomethane to grid was 2014. We've been doing electricity from biogas since the late 90s. Maybe, well, as I say, originally a lot further back, but properly from the late 90s. And for a long time now, just generating that renewable energy has been a fantastic step forward in the way that we're transforming the UK's green agenda. But it has to be said, it's starting to look more and more like if we're going to start hitting the carbon targets that we need to look at every opportunity that we have for how we can do a little bit more and how we can generate in cleaner, greener ways. So we're looking more and more at carbon capture technology, and there are others out there. This is one that we are in the process of commissioning at our Birmingham site at Minworth at the moment, where we're looking at the possibility of taking, so when we do that extraction in the biogas to grid plants, we can get quite a rich CO2 stream. Historically, there's been the potential to vent that up into the atmosphere because it's naturally produced CO2. This is just from kind of the natural breakdown of organic material. So we're not producing new CO2, but we're also not removing it from the environment. What we're considering here is the ability to remove carbon dioxide, combine it with some other waste materials that we have on a sewage treatment works, and produce something that can be of real value. So this is where we can take that carbon dioxide, react it with ammonia from our final effluent streams, pelletize the material, and actually end up with something that is a useful fertilizer product for farmers that can almost be tailor-made. And when it's put onto the land, we'll also be able to sequester carbon. So essentially, this is carbon dioxide that, whilst it's naturally occurring, we're able to pull it out of the environment and sink it into the ground where it's both to an extent locked away, but also providing future value to the crops that are being grown on that land. So it's taking us forward to that next generation. Now, there are other things you might have heard in the news recently. People are looking at capturing this CO2 and injecting it into the North Sea. There are loads of ways that we're looking at improving how we can generate cleaner, greener energy from what is essentially one of the worst waste materials out there. And this is the one that we're looking to make a step forward with first. So then just asked to move on to what I think is the last slide. Yeah, so just a sort of a bit of a summary here, really. So at Severn Trent, we've committed to some fairly serious carbon improvement targets with our triple carbon pledge, and going that little bit further and talking about science-based targets. As bioresources, we have a huge part to play in that, both in terms of the emissions that come from our processes, reducing those, and looking at how we can grow the really good side of our business, that is capturing and producing renewable energy from this one of the worst waste materials that's out there, and how we can grow that technology across more feedstocks and sites if possible. We're currently in the process of building more advanced AD plants, so that helps us both to reduce the emissions of the processes that we're operating, and it allows us to produce more biomethane that can be upgraded and put across the various networks and opportunities that will allow us to achieve our carbon goals. And ultimately, one of the big things we're looking at is how can we utilize the high value products that are being produced, either in this case carbon dioxide, but there are others out there in terms of ammonia and potentially even things like cellulose, that we can recover and utilize in other processes or provide to other industries, that mean we're not wasting anything and that we're taking all the value we possibly can from the waste. So yeah, I guess the overall message is there at the bottom, that we've now established a route whereby we can get biomethane into the grids. We're now looking at how we can use it differently, how we can push that on for the next sort of generation of renewable energy technologies, and how we can align that to all of our carbon reduction ambitions. So I hope that's been useful. I think the Q&A is going to be at the end, so we can ignore this final slide, and I think I'll hand back to Jason, I think.
Okay, so many thanks, Simon, for that excellent presentation and fascinating insight. I love it that we get the opportunity for more people to get excited about sewage. So if you can just kindly sit back and enjoy our next presentation, and we'll come back to you a little bit later with some questions. Okay, so next up we've got Philip Woodcock from PBF Drainage. So Philip recently retired after working in a wide selection of commercial roles, spanning a 40+ year career in the construction industry. Philip became the UK General Manager at Per Arslav Pipe Technologies, and he was responsible for introducing their CIPP line into the UK. He's presently supporting various companies to win business in both the public and private sectors, and is currently involved with PBF Drainage, bringing the Bluelight technology to the UK. Bluelight technology is the subject he's about to share with us. So I'll hand straight over to Philip to tell us more. Over to you, Philip.
Okay. Good morning. Thank you, everybody. Thanks, Jason. Thanks to Simon. And generally, thank you to Severn Trent for inviting us on to talk about Bluelight. I remember Bluelight being first demonstrated in Denmark 10, 12 years ago, and it's really come a long way. The difference is that it is actually cured by using LED light. And this second slide is just showing the history of the development of LED. And it was actually developed to be used by Per Arslav only initially, and then slowly but surely it was extended into Germany, as you can see there, and now it's in the UK. Now, using LED lights, it's actually using light to cure the liner rather than heat. So you can see here, I'll just bring out a couple of points because you can see it all yourself. The light is there. Excuse me, I'm just looking for here. There is a reduction of error potential compared with two components. So therefore, you're using the installer and the liner from the same producer. Okay, move on from there. The advantages to the engineers, planners and architects. It helps the project management. It's a fully automated system. And it's reduction of error because you're only using a one component system. And as it says there, you can go up to 95 meters in length. Excuse me. Now this is a picture of the actual equipment. As you can see, it's lightweight, portable. It has two LED heads at the end. The shorter one is where we use it in laterals, where you've got quite a few bends. The longer one is where you are lining in straighter lines. It's portable. The only extra you need there, you need a compressor and a generator. There are three standard linings available to be used with this. As you can see, the first one is a flexible liner based on synthetic fibre with PU coating. That's to be used in laterals or inside buildings. One of the biggest advantages is it's styrene free. So you're not going to get any complaints from people if you're lining from the street into their cellar, complaining about styrene, which is quite a large advantage. The second one, the PAF liner 3D, is slightly different. It is styrene free, but it can actually change the expansion. You can change the diameter of the pipe. You can line from 100 to 150 mil. And that again is also put in as an inversion process. And the last one is a non-flexible GRP liner for mainly straight lines. Again, styrene free. So again, you don't have any problems with complaints from that. Here are some pictures of the actual blue light being used. It's called blue light because that is a natural colour that the LED light gives in this particular stratum. So you can see they're going down into road gullies, various pipes, sewers, big sewers at the bottom in the middle there. And also it can be used inside. The picture on the right hand side is actually being used inside, I think it was a hospital. Now, we don't in this country have too many pipes inside because our temperatures don't get down to -20, -30. But in the continent, Europe, east, further north, a lot of their pipes are inside and therefore they can't rip them out, so they have to line them. This is just a documentation of the curing parameters. It doesn't really tell us from where we're sitting here too much, so I'll just move on to the next one. Now, this is where we say that AD technology is superior to, for example, a UV gas lamp. 100% of the output power is emitted in the wavelength of the photoinitiator. So we have the efficiency of 67% power output with LED. The UV, and this is not a criticism, it just is, the output power has several peaks over the whole spectrum. So a huge amount of energy cannot be used by the photoinitiator of the resin. Therefore, we've calculated that the efficiency of a UV gas lamp is between 15 and 20%. So there you've got nearly 3 times more efficiency with the LED than you have with the UV. Okay, again, and then we have differences in the lateral light cure, the different heads. Again, both showing the key figures here are both showing the efficiency of 66.7%, while the UV LED product is coming in between 28 and 30%. And then the one at the bottom is an efficiency of between 15 and 20%. So you're putting in 100 and you're getting out 166. You're putting in 100, you're getting out 128. Massive difference in energy and efficiency. Again, on reliability, the LED system does not have any moving parts. It has a specially patented cooling system which prevents the moisture contaminating electronics, and all air passes through the specially designed fans inside the light head, which then exits through the front of the head, never contacting the bulbs or other components. So there are no moving parts, therefore there is a lot less chance of anything breaking down. And it was carefully considered, the construction of the blue lights, of the working environment. It's damp, wet, in sewers, in the rain, freezing temperatures, etc. So it really has been designed to be able to work in all sorts of weathers with minimal problems. And unfortunately, other manufacturers, their heads have rotating heads. Therefore, there's more chance of the moisture getting into the electric components over time and therefore causing problems. This is just showing the quality of the lining performance against various criteria: water tightness, modulus elasticity, flexural strength, etc. On the blue light PAA F line at the top, you can see the results there. And then you have other liners going further down. Now, all the curing speeds are computer worked out. And the different heads have two different curing speeds. There you have the PFA liner 153.5, that's the thickness, will cure at 63 meters an hour, produce a pure liner at 63 meters an hour. The 300 diameter one, which is obviously bigger diameter, can cure at 99 meters an hour, which you might think is a bit strange. But generally speaking, the 150 diameter is being used in sidelines, in laterals, smaller pipes. Therefore, we have to cure more slowly because you have more imperfections. As you can see from the picture on the right-hand side, you have bands in the pipe and the different thicknesses and bends. So we actually factor in a safety factor of 3 into curing speeds for the flexible liners compared to the main lines. So that's just so it takes longer to make sure the job is done correctly. The curing speeds have been worked out over the years with more than sort of 60,000 installations, 400,000 meters of installed liners only on sites with per hours left. Because the liner production is also the liner machine production. Blue light is designed, manufactured and used by the one supplier of per hours left. So this reduces any issues with using a different machine with a different liner, a thinner liner, a thicker liner, which can result in poor quality, insufficient curing, incompatible lining. So, and you can get severe delamination, uncured resins, and insufficient strengths if you mix and match different liners with different machines. There are currently 8 UK installers of blue light lining system in the UK, and PBF Drainage have a wet out facility in Northampton with the capacity for 8,000 meters plus per month. And I'll just go on to the last couple of slides where really these are the sort of conclusions of what we've been talking about. We've calculated that the LED gives a 90% reduction in CO2 usage compared with heat curing systems, for example, steam, for example. LED cures with light with a very steep curving curing curve and so reduces energy consumption. It does not contain styrene and therefore no smell. Also a single component resin, so there's no mixing required. So you're not putting 2 resins together, you have 1 resin. So you're reducing cost and environmental risks and reducing the need to the disposal of unused chemicals. There is restricted access for internal and external use. You've seen the size and picture of the unit. Therefore, you're reducing labour costs and requirements and increased portability, which reduces transport costs. So we are basically talking about a 2-man team with a van, and they can go out anywhere and they can just reline using the LED system. The speed of the installation is 1/3 of that of steam, and therefore reduces power consumption, energy consumption. The LED, blue light LED, can line around 90-degree bends. It can line in changed dimensions, and it can line open-ended reusing calibration hoses multiple times. There is harmonized LED equipment and liners from one source per hour's left, and so reducing deliveries. The liner in the UK has a WRC approval, and in Germany it is approved by the DIBT. The local UK liner supplier, that's PBF Traders in Northampton, ships the liners in bulk from Germany, therefore reducing delivery miles. The long storage of impregnated liners, so clients can bulk buy also. The impregnated liners can last for weeks and weeks and weeks. Therefore, if, for example, a contractor had a contract for 6 to 8 weeks, you could buy all the impregnated liners right at the beginning in one go, therefore reducing miles. There's automatic pullback of the LED head, it can control curing, and so less potential problems. LED cures between 60 and 80 meters an hour, therefore reducing, for example, over-pumping requirements, and you're handing the asset back more quickly to the clients. The LED efficiency is 67%, while UV is 15 to 20%. So there are massive CO2 savings here as well. Blue light can line between 100 millimeters and a 400 millimeter diameter, up to 95 meters in one shot. This means you have more productivity with more liners being installed per shift, reducing site visits, and you can use the same equipment for both felt and glass liners. The inbuilt camera in the head of the LED ball produces an as-built report while curing. So as the head is being pulled back and is curing, it's filming at the same time. Therefore, you do not need another CCTV vehicle, saving CO2. And generally speaking, this is from the UKSTT point of view, really. Trenches repairs, reduce the need for excavation, no waste disposal, less transport to sites, etc. This applies to all sort of trenchless technology. Equally, small portable equipment reduces lane closures, road closures, and standing traffic. Okay, that's me finished. Thank you very much.
Okay, so that should be me back. Okay, many thanks for that stimulating presentation and sharing the technological wizardry with us. Thank you very much. Anybody who's worked on projects involving lining will appreciate the benefits of having a controlled in situ curing system. So that's really good. I'll hold back the groans, but this really has helped us to see the light. So sorry about that. If we can run into the Q&A session, if you keep your questions coming in, we do have a few. If we do run out of time, I promise we'll follow up and share responses to them afterwards. But just to give Philip a moment, I'm going to ask Simon the first question, if that's okay. So, Simon, question is, how much energy can realistically be produced from sewage sludge and digesters, and how much impact can it have on the UK market?
Okay, so obviously the one disadvantage we have with sewage sludge is that it's already been digested twice, effectively. So, it's already been processed once, digested by us as humans. So it's not quite as valuable as some of the food waste materials and the crop materials that are out there. But as a business, so I said earlier, I think we produce around about 251 gigawatt hours of electricity equivalent every single year. Now, what that means is it's roughly enough to power a city the size of Gloucester. So that's from Severn Trent's perspective. That's kind of the volume of energy that we're putting out there onto the networks. If we convert it all to biomethane, it's sort of much harder to gauge. But we can, when we look at the sort of overall UK energy mix, and if you take into account some of the food waste and some of the crops that are out there, if everybody starts going for biomethane, we could probably end up supplying around about 50% of the future UK heating needs. So that's quite a big 2050 type assumption. But certainly there is huge potential in the use of anaerobic digestion as a technology in general. And as I say, from a Severn Trent perspective and focusing purely on the sewage, yeah, we're producing a fairly sizable amount. And in our case, we're looking at using it to power the water treatment process. So around about, I think it's about 52% of our energy needs as a water business are met by our own production. As I said earlier, the rest is sort of topped up by a power purchase agreement.
Okay, thank you. Could I just ask if you could keep me in check for time, please, Norman, because we have got a few questions coming in. So next question that I've got is for you, Simon, again. So it says, converting your vehicle fleet to electric is laudable, recognising your caveat where technology allows. However, in the case of high pressure water jetting sewers, clearly this will not be possible. As these vehicles are amongst the heaviest and highest polluting vehicles on the UK roads, given their virtual continuous operation, whilst moving and performing their operation, could you answer why more isn't being done to promote low-cost automated sewer cleansing solutions? Flusher 2 being one example. These are designed to clean and keep clean and require no HGV vehicles for installation or occasional maintenance.
So in terms of the first part, I've probably got a halfway. I might struggle a little bit with the sewer cleansing side of it because I'm not so close to that. But in terms of these vehicles, I guess, yeah, so the caveat was there where the technology allows. And that's simply because right now we don't know what the best low carbon solution for the technology types that out there is. If you said to me 5 years ago that electric cars would be in the position that they're in now, I'd have probably been a bit skeptical. And I think we've got to look at it and say it's by 2030, there is likely to be a huge change in the sort of fuels that we have available and how we can consume them. So whether things that require sort of high pressure pumps or things like that would be more suited to a kind of a compressed gas vehicle or having compressed gas fuels on there, whether we even look at biodiesels, they're starting to grow as well, coming from fats, oils, greases, that type of material. Potentially even the stuff that is being jetted out could be converted into a fuel that may be more suitable for those vehicles. What we do know is that the sort of vehicle manufacturers are starting to get into a place where they are considering alternate fuels and what they can do differently with what they've got there. I quite like the sound of the sort of the more automated solutions around sewer cleansing. I'm afraid I'm not part of that part of the business or the innovation that sits alongside it to know why it's not being picked up at the moment. So I'd hate to give an answer one way or the other on that. But yeah, from a vehicles perspective, as I say, that the market is developing, the quality of vehicles and the types of fuels are expanding all the time. So over the next 9 years, we expect there to be reasonably significant movement in all areas of transport.
Okay, thanks. I think it's probably fair to say as well, Simon, that as an overall initiative of our general efficiencies and carbon reduction incentives that we've got, I can well imagine that although it might not be a direct result of the presentation you were describing and the opportunities that we are looking at there, but I think in general, looking at the processes that we would employ to do sewer jetting, as an example, would be something that we would look at in its own right. And so if there was a lower carbon or a more efficient, better for the environment process, we would look to exploit that separately anyway.
Yeah, so I think sort of
it's worth process. Sorry?
Yeah, I mean, we're looking more at sort of how we can do an internal carbon tax is the best way to describe it. So actually, not all low carbon technology at the moment is a great financial business model. So where we might be able to make savings in terms of carbon, we don't necessarily see the same reflection in OPEX or CAPEX reduction. So what we're looking at doing is creating an internal carbon tax type mechanism that means that when those business cases come forward, they become significantly more attractive on the basis of the carbon that they can save rather than just pure financial return.
Yeah, okay. And if somebody wants to send us details on the Flusher 2 system as an example, we'll feed that into the system, and we'll get that one considered and looked at on a individual basis.
Yeah.
Okay, lovely, thank you. So just give Philip another moment. One more question for you, Simon, and then we'll go over to one for Philip. So question is, I'm interested to understand if you're having discussions with the gas network owners with regard to how biomethane fits with their aspirations to introduce hydrogen into their networks. And are you considering using biomethane for hydrogen production?
So in terms of, yeah, we have a pretty good relationship with Cadent, who operate the gas network broadly in our region. We've got a couple of occasions we've had conversations with Wales and West Utilities as well. So yeah, we are in conversation with the ones that we work with. I think there's been a really good report issued recently by Cadent that sort of outlines their journey towards more dedicated hydrogen networks, but also looking at potentially blending methane from waste and hydrogen into the network to create more of a hybrid fuel that could be used in all the situations that we've talked about. In terms of progressing that biomethane through to hydrogen, it's something that we are aware of. We know, so give another company a shout out, I guess, the guys at Welsh Water, Dow Cymru, they've started looking at whether steam reformation of biomethane to power the council fleets down in Cardiff could be an option. And I think there's a mix between the two, so it depends on what you want the end gas to do. So if you want hydrogen to go into vehicles, so you've got low tailpipe emissions in a city centre, it's a good pathway fuel to get to that. However, if you're looking for high efficiency energy recovery, we've got to remember that steam reformation takes, or that process step will make an efficiency. And so if you factor that efficiency in, you'll end up with less energy from your gas. So you end up with a less dense fuel that you've probably expended a bit of energy to get to. So I think there's going to be a blend as we move forward in terms of the types of energy that end up in the network. If we go completely dedicated hydrogen network, the route is there, and we'll look at improving the efficiency for it. So it's kind of a no regret strategy decision really to start producing the methane in the quantities we are.
Okay, lovely, thank you. Okay, Philip, do you have any information regarding how effectively Bluelight method mirror the host pipe and secure to the host fabric? Have you reliable evidence in terms of in-pipe accurate profiling confirming pre and post installation?
I think James could pick up on that one. Are you ready?
Yeah, Philip. With regards to the actual forming to the host pipe, like all CIPP liners, they will conform to the host pipe. We've got some very good pre and post CCTV surveys of the installations. They will adhere to the pipe to a certain extent, depending on the host pipe material. We don't get any shrink back on the liners, so there's no annulus between the host pipe and the actual the liner installed. So yes, they will bond, but only in certain circumstances. It's more of a mechanical fit. You can vary the liner thickness between 3.5 and 4.5 millimeters. So depending on the amount of bends negotiated, the defects in the pipe and the pipe depth, you would increase your liner thickness according to groundwater pressures and other factors like that. And the thicker the liner, you're going to get a reduced impact or a visual impact inside the pipe, or inside the liner, I should say, once it's actually been installed. So if you have got a large void or anything like that you're lining through, you would use a thicker liner to reduce any visible deformation within the pipe.
Okay, lovely. Next question I've got. is, it says, with the greatest respect, visual CCTV of a white liner cannot show defects in liner adhesion, unless this is significant. Are you able to offer a comment on that?
Yeah, the liners are actually, it's a watertight liner, and we can do pressure tests, internal pressure tests with the liners. And these, with the WRC approvals, all the liners are WRC approved as a watertight liner. So generally they're the only ways of doing it. You can also use the electroscan system, and there are a few other sort of systems that can detect defects within a CIP line pipe. And so far we've not had any failures that we know of with regards to actual defects within the line pipe.
Okay, thank you. So back to you, Simon. Comment is that was a really good presentation. Is producing hydrogen from biomethane something that you're looking at, or is biomethane to grid route the most beneficial for Severn Trent economically at this time? Could future government incentives change this balance?
Yeah, so it is a good point that we are, as an industry, quite reliant upon government support for developing the new technologies and really establishing that foothold in the market. I think, so we are aware of the possibility of converting the methane over to hydrogen. It is something that we could do, and the technology is actually reasonably well established for that. I think at the moment, as I said in the last answer, I think we have to look at the efficiencies and the relative carbon merits of doing the two to understand if the value in the whole supply chain ends up being best placed. But right now, yeah, we've just commissioned 2 biomethane plants to go with our new advanced AD facilities at Nottingham and at Coventry. Those 2 sites are going to be supported by the government's renewable heat incentive, which is just closed. And definitely injecting it into the grid is the right way for us to go now. As the gas grid changes, as opportunity changes, we'll obviously consider what's out there, but in the here and now, yeah, injecting into the grid opens up the most end uses. We can replace the power that we might have produced from some of that with other forms of renewables, so decarbonising the gas network is definitely the preferred option at the moment.
Okay, thank you. Okay, so Philip, question is, are the liners that are used with the LED light system, are they sensitive like those used with UV light, and do they need any protection from natural light prior to installation? Is any specific installation equipment required to protect them?
Okay, I think James again is probably best to answer that one.
Again, with all light reactive resins, you do need to protect them from the natural elements as such. We tend to go back to the old school method of installing liners via an inversion drum. But again, they can be installed with the newer system with a sluice. If we are working out in the bright sunlight, we would just put an awning over the top of us, a very simple gazebo, pop-up gazebo or something like that. But generally, if you're installing fast liners relatively quickly, they're not going to be open to the elements for more than sort of a few seconds at a time, realistically, if they're being installed correctly. So far, we've not had any issues with the effects of general sunlight. It's not designed to be installing, hundreds and hundreds of meters in one go. So it is more designed for the lateral lining system, where you're installing shorter lengths up to 100 meters, where you don't generally have the liners out in the open for such long periods of time. Again, just to add to that, the glass liners do actually come in a protective foil, very, very similar to, they're exactly the same as standard glass liners. They've got an inner and outer foil on them, which protects it from the natural sunlight, just because the process of installing a glass liner is slightly slower. But your curing speeds are increased, so it's where you're taken away from the speed of installation, you're speeding up with the curing process.
Okay, lovely, thank you. Simon, back to you. Is there potential to use solid byproducts from potable water treatment as an AD feedstock?
So I think this is referring to, so we do have, so the clean water sludges coming off the water treatment process. So we do tend to occasionally bring them into sites, but they tend to be quite low organic, quite inert type materials. So we don't get a huge amount of benefit from them. There's one main upside that we can use it for, is that sometimes the metals content, so we use things like iron in various quantities to control hydrogen sulfide production, which can be a bit of a nuisance for both environmental and mechanical reasons, that we don't want it damaging the equipment that's on site. So there are instances where it can be beneficial to bring in small amounts of clean water sludges to actually sort of facilitate the reduction of these problem side components that are coming out in the gas. But generally speaking, when we've looked at it and we've tried to put it into digesters, we don't see any energy yield from it because there's just no organic content for the bacteria to break down.
Okay. All right, thank you. Philip, question, can your equipment be scaled up to extend the pipeline diameter range that can be lined?
Are you happy for me to answer this one again, Phil?
Yeah.
As with all curing systems, there's ongoing development all the time. There's ongoing testing being done, literally every day with larger diameters, longer lengths. Generally, it becomes less cost effective to use this system on the larger diameters, purely because of material costs and the specialist resin costs. At the moment, resin prices are increasing day by day. So we are, we're not doing too many, developments at the moment, purely because costs are restrictive. The larger the diameter size, and you're much, with the larger diameters, you're better off using a traditional system or a standard UV system, because the cost comparisons and the CO2 savings start to merge, and one will overtake the other.
Okay, thank you. Back to you, Simon. The comment says, thank you for the webinar all. I have two questions. Firstly, what are the implications of increasing synergy between gas and water in terms of supplying energy in a low carbon environment when it comes to the regulation? A previous question highlighted just one of the interactions between GNOs and yourselves. Could we see Severn Trent starting to supply gas itself in the medium to long term? That's the first part of the question, so we'll do that bit first.
Okay, so the short answer is almost certainly no. The way we would look to do it, so the way that the gas grid's divided up, we end up with essentially the network owners who are quite heavily regulated. They have quite severe legislation they have to adhere to, so things like the Gas Act and the gas safety management regulations that we sort of tiptoe around the edge of. We do comply with, but more at their behest than anything else. So I can't see us looking to take on a kind of a gas network operator type role. I think from our perspective, if we had surplus, and we do occasionally, so green power in particular, we will have gas that isn't necessarily going back into Severn Trent Water's usage. We do look to set up gas purchase agreements, so where other companies can make use of the materials that we're producing. So be it power, be it gas, if it can be used locally or it can be used more effectively, we'll have a power purchase or a gas purchase agreement between ourselves and the third party. That means other people can benefit from the energy that we are producing. So I don't see us stepping into the regulation. To be honest, working with Ofgem as a regulator for just our incentives is enough. I think the workload that could come with everything else would be quite traumatic and quite sizable for what is at the moment a relatively small volume of gas that's going into the network. So from a supplier perspective, I guess we might put purchase agreements in place. I don't think we'd be keen to get into the shipper or network operator side of things. That's too much for what we're doing.
Okay, thank you. So the second part to the question, it says, there wasn't much clarity on the various options around CCS. Is my understanding correct that Severn Trent are looking at fertilizers and storage of the captured carbon, such as in the North Sea, or are there any other notable lines of inquiry, such as carbon-based construction materials, etc.?
So we've got a very wide carbon program that's just started out that's looking to capture all the good ideas that we can find out there. So the bit I'm talking about here is really around the energy production and how we can make that greener. So we're looking at carbon capture off CHP exhausts. We're looking at carbon capture from several of the biomethane plants. We're also looking at how we can reduce our process emissions. So we have reasonably high levels of methane emission from various processes that we've inherited historically. That said, if you move into the wastewater side of it as well, so onto the effluent treatment, we're looking at technologies that could potentially replace or reduce the amount of emissions that come from our ASPs. If you go to other parts of the business, there are many, many more things that are being looked at in terms of how we can reduce carbon in the way that we operate. We just know that from a bioresources perspective, the processes that we use, whilst they're great generators, we also have to look at how we offset that. Now, we could even go so far as to say we just want to naturally withdraw CO2 from the surrounding environment. So we are actually, in all of these areas, we're looking at technologies that could simply extract CO2 and store it in some way. We're looking at some nature-based solutions in terms of using the water cycle more effectively to store some carbon. I should know a little bit more about that, but I don't, unfortunately. I know they're using how riverbeds sort of naturally form to actually contain some of the carbon that's coming through our water treatment processes. So there is loads and loads of stuff that we're doing in the carbon space. What I've given you today is kind of a snapshot of what is roughly a sixth of the business. There is a huge amount more that's going on in our carbon program, and I'm sure there'll be plenty of other people that will be keen to talk about their areas of the business as well in future seminars.
Okay, lovely, thank you. We're certainly getting some challenging questions coming in for the presenters today. So next question I've got is back to you, Philip. How do you confirm the efficiency of the curing when the light head is pushed or sliding in the liner invert?
The system actually reads or takes a protocol of the full installation. So from the first or from the initial install, it takes a reading of all your pressures, your temperatures, your power output and everything like that, and it records that on the system. And then the system actually, it's got a built-in program that will only allow the system to draw back at a certain speed. As during the presentation, it said we've got a safety factor of 3. So even if you've got multiple bends in there, you've got some size increases due to diameter changes or size decreases, you've got a slight thickening due to a deformation in the pipe, or obviously when it goes through a joint or something like that, you've got a slightly thicker material in there because of the resin saturation. So this safety factor of 3 will actually take into account all those different factors, record it all, providing a fully cured liner, and the protocol can actually be presented to the customer at the end, which can be downloaded off the system either at the end of it, at the end of the job, or it can be emailed over.
Okay, lovely, thank you. Here's an interesting one, Simon. Could the waste CO2 from the AD process be scrubbed to a point that it could be used for drinks production and human consumption?
Yeah, so it's quite an interesting one, this one. So we do know that if you look at AD in general, we do know that there are some crop-based plants, which is essentially a product, it could go into the food anyway, that they are producing the CO2, they're collecting it, and they are scrubbing it to food grade quality, and it does go into various food processes. Now, when we get to the other end of the AD scale, and we're talking about sewage, I mean, at the end of the day, it's carbon dioxide. It is a simple chemical, a fairly simple chemical compound that could be used in any of the processes that carbon dioxide is used in. What we've experienced in the past when we started to ask about this from a sewage perspective is, I think there's a reputational and a marketing and brand issue that could come with it if a fizzy drinks manufacturer was suddenly found to be making their drinks fizzy with gas that had come from sewage. I think that would be, from a marketing perspective, could be quite damaging. But we do know that there are other sort of processes. So for example, I think it's welding is a good example of one, where CO2 is quite readily used. And if we cleaned it so that it didn't have any impact on the process it was going to, absolutely no reason why it couldn't be used. There is a possibility, of course, of just pressurizing it up and sticking it under the ground somewhere, but we think there could be more value in it for some of those processes that go into other manufacturing that isn't necessarily food grade.
Okay. Yeah, sewage flavoured fizzy drinks. That doesn't sound great, does it? Thank you. Question for Philip. All polyester resins have a shrinkage effect. What kind of polyester resin do you use?
Again, sorry, Phil. We're not actually using a polyester resin. Ours is a vinyl ester resin. It's an LED light reactive vinyl ester resin, which is obviously vinyl ester is based on epoxy. So as long as the line has been cured properly and all of the protocols have been completed correctly, you shouldn't get any shrink back.
Okay, lovely, thank you. How are we doing for time? Are we okay to? We've got a few more questions still to go. Am I okay to keep going?
Yeah, I think, Jason, we'll perhaps have another 5 minutes or so.
Okay, thanks, Norman. So, Simon, can I ask you, with a growing challenge on final effluent quality, how does that impact the sludge that you treat?
So yeah, this is a tricky one, because obviously as the final effluent quality grows, so does what's coming through to us. Now the sludges that are produced by some of the more energy intensive processes on a wastewater treatment works are not necessarily the easiest ones for us to digest, and that's where these sort of advanced AD technologies are starting to come into their own. So the additional production of sludge from, say, an ASP that's having to work harder to reduce phosphorus can be beneficial to us, provided we get it going through the right energy conversion process. So we will be producing more sludge that does have some organic content that we can access more of and treat more of. So in some respects, there's a bonus there. There's also a bonus with things like, as I say, if it is a P consent, for example, that is actually something that is useful in the biosolid fertilizer at the end of the process. So having that in the material is not a bad thing. Where we may well start to have more of a challenge, if you like, is as we start to look more at the kind of the micropollutants, the microplastics and things like that that we expect to come out of final effluent. They still have to go somewhere, and how we manage that balance with what goes to land, what's naturally occurring, what we have in the catchment, there is probably more challenge arising from that. So increasing the quality of our treatment isn't necessarily a huge problem, although we do have to be careful about how we blend the secondary sludges and the primary sludges to make sure that our digesters can function. But with the enhanced processes that are coming through, we can actually use some of it to produce more gas. So it's kind of a double-edged sword, really.
Okay, thank you. Question for Philip. How do you record the curing results of the LEDs?
James, I think we've covered that, haven't we? James?
The results of the cured liner, they're recorded on the system in a protocol. If you do ultraviolet light cure lining, it's a similar type of protocol reading, whereas it reads the temperatures, the internal pressures, the speed of the actual pullback on the cable, and it also records your power consumption. And this is all recorded on the system, which is then downloaded onto a memory card or a memory stick, which can then either be emailed over to the client as a full CSV file or any type of Excel file, or even a PDF. and the client can have that as a result. And that will be in a, like I say, a spreadsheet, but there's also a graph that's included in it demonstrating the actual curing speeds.
Okay, thank you. If I just have one last question for Simon, and you did touch on this before in the previous question. So a question is, are there any risks for putting the biosolids onto land, microplastics and other micropollutants being known currently?
Yeah, so this is something that's sort of growing as a concern, is the amount of microplastics that are coming down through the sewer and into the sludge. And I think it's right that we're concerned about it, but at the moment we've got to look for a better sort of evidentiary basis for whether it's entering or where it's entering the end use, what's it being used for, because some of this stuff is now in the environment. We can't get rid of it. So it might just be cycling round and round and round, and we don't know that. What we do need to understand, though, is what the impact of having those things in the sludge cake are, and either how we can remove them or how we can use them in the right context so that we don't pose any risk. Well, we don't pose any risk anyway to human health. It's just being mindful of the fact that the list of things that might come down the sewer is constantly increasing. So right now, you know, microplastics are one of the ones that everybody's focusing on, but I'm sure there will be more challenges as we move into the future. So yes, there's always a risk waiting around the corner. We just have to make sure that what we're doing poses no risk to anybody else, and the activities we do are governed and safe to follow.
Okay, thank you. So we're about up on time for the Q&A, so I'll draw that to a close. As I said before, if there are any other, if the unanswered questions that have come in, or if there are things that you have after the session that you wanted to check in with, if you send those over to us, we'll make sure that we get a response out to you and share those around. So just as a reminder, remember that the session will be available on the Guild and the UKSTT YouTube channel, so it will be there for you to share with your colleagues and your friends and family. On behalf of the UKSTT and the Guild itself, many thanks for both the presenters. You've had some challenging questions to respond to, great presentations. Are we able to briefly unmute and give a round of applause to show our appreciation? Is that possible? Well, whether we can or not, I'm going to be clapping for everybody else. So, thanks very much for your time and the hard work that you put into the presentations and those tough questions that you've had to respond to. So thanks also to the teams who worked very hard in the background to make the session work. I know it's been a difficult thing to manage from a virtual basis, and I look forward to seeing you all again at the next event, maybe in person. So if you enjoy the rest of your day, I'll hand you over to Norman to close out.
Okay, thanks, Jason, and thanks to the two speakers. As Jason said, really good presentations, and you certainly generated some great questions. So thanks for that, and also thanks for all of you for attending today's session. As you can see on the screen, our next Green Alliance webinar is on Tuesday, the 20th of July. Where we've got Mike Elmer, who works for National Grid. He's the project director of the Viking Interconnector project, and we'll be looking at interconnectors. What's the fuss about? So we're looking at that, and we're moving here from gas and storage to looking at what the electricity industry are doing in terms of net zero. And then after Mike, we've got Scott Stone, who's the operations manager at Volker Trenches Solutions, and he'll be providing us with a presentation on horizontal directional drilling. I'm pretty sure it'll revolve around bringing those interconnector cables from the sea to landfall. So if you look out for that, again, you can register for this webinar on the UKSTT or the Pipeline Industries Guild websites. So I'll close today's session now. Thank you again for attending. And as I always say, we're always interested in getting your feedback. So if you've any comments about our webinar program or any of the other events, then please let us know. And if there are any topics that you'd like us to find presentations for, again, please get in contact with us and we'll see what we can do. So without further ado, I'll say now it's good afternoon and it's time to go and get a bite of lunch, I think. So thanks again, everyone, and I look forward to speaking with you soon.
Thanks all.
Cheers.